So who here makes a product? Who's a manufacturer of products? All right, good. Now, of you, who is using radio modules to make their product radio-enabled or thinking about doing it? All right, plenty of people. Good. Okay, so here's a little slide with the QR code. I think you'll have copies of these slides, and so you can scan that one. So this is me. My name's Michael. I've been in this industry for about 35 years. I am an engineer, but there are no equations or maths in these slides. I've been doing this testing and approvals for a long, long time, and I've probably spent about the last 10 or so years really focusing on this topic of radio modules because it's really quite complicated. Okay, so some of the goals for today then. I really want to talk about what a manufacturer's end goal for placing their product on the market is. Like way back before the whole, I'm going to do a test, I'm going to put a module in. What is your ultimate game? And then we're going to talk about radio modules. And if you buy in an approved radio module, what do you actually get? And what does it mean to you? And then what does it do when you combine it with some other product? Like you've got a washing machine with Wi-Fi, or a printer with RFID, or a laptop with Wi-Fi or cellular. We'll talk about this from an engineering point of view and a legality point of view. And people forget sometimes that these are two very different topics. And hopefully I'll have some questions and answers at the end. I would gladly talk about this topic for about 2 days. So the fact that I'm going to condense it to less than half an hour with a Q&A, let's see how that goes. So who is the manufacturer, right? So I started working for a commercial test. My first job was for a manufacturer. Then I started working for a commercial test lab. When I started doing radio testing, I'd be in my office and the receptionist would call up, Michael, your customer's in reception, go and pick them up. And I would walk in, and there'd be a sea of faces, but I knew straight away who was my customer, who was the radio equipment manufacturer. They had a certain look. They knew exactly how their product worked. They probably slept with the antenna specifications on their pillowcase. They knew about all the modulation and the bandwidths, and they really knew their product. And that was great, because as a test engineer, I could have that conversation with them. Over the years, though, the industry has changed a bit, and now you've got people who make things, and they want to connect those things to the internet, expression like the Internet of Things, for example. And so suddenly, the person who's getting into all the adventures and all the excitement happens to them isn't actually the person who made the cool radio product in the first place. So you've got the radio manufacturer, and then the person who's getting into all the adventures with it. And that's kind of how it is, where you've got a manufacturer might be an expert in washing machines or printers or power tools, and now they need to make it radio-enabled with Wi-Fi or Bluetooth or RFID. And so this is a real challenge for the industry, and we've kind of created this radio modules and products industry. Now, for any manufacturer wanting to place a product on the market, your job is really quite simple. Your job is to sell a product that people will want to buy. Or maybe they'll want to buy more of them. They buy one and then they want to buy more. Or if it breaks, they want to just replace it with the others. And they'll tell their friends, and their friends will say, I'll have one of those as well. So you've got to be able to sell it, and it's got to perform well enough that everybody wants another one and writes a great review of it online. That's your job, really, as a manufacturer. So that's what you want to try and remember. Don't think about, waking up this morning, I'd really like to go and do an ESD test. Think about, I want to sell a product, and it's got to be a good product. Don't lose sight of that goal. And when you're talking about regulatory approvals, it all comes from those goals. Regulatory approvals might seem like a real headache at the end of your production sample, in the same way as a car MOT might seem like a headache for a motorist. And sure enough, when you're 18 and you're driving a 20-pound car, it is a real headache. But when you're an old man and you've got children in the back of your car, you're like, I'm really glad that the brakes of my car work okay. Regulatory approvals tests weren't just dreamt up. It wasn't just a bunch of engineers sitting around kind of going, I know, we'll have this big spark gun and you can do an ESD to it, and then we'll get transients on a cable. It wasn't just dreamt up. Every test, whether it's safety or EMC or radio or cybersecurity, comes from fixing a problem which existed. So the whole point of regulatory approvals testing is to make the product good, okay? And you can't sell it unless you've gone through that process. So all these tests were created for a reason. If you want to sell your product and it works well, the regulatory approvals shouldn't be seen as like a headache hurdle. It should be seen as this is a good way of checking my product is okay. So I mentioned at the beginning that a lot of people think of testing and approvals as one big topic, like my product passes the tests, so I can now sell it. Or, well, this product's got an approvals marking on it, so it must pass all the tests. And they are similar topics, and we talk about them at similar times, but they're really two different topics. There's testing to check that a product works okay, but then you still need to go and get some approvals done. Even if a product's been tested, there's still a sort of legal approval step. And similarly, if you've got a product, like a radio module, and it's got some approvals markings on it, it was probably tested in a situation, but that doesn't mean that you don't have to retest it if you change how that product is being used. So when I say radio module, what do I actually mean? If I handed out a piece of paper and a pack of crayons to everybody and said, draw a picture of a radio module, I'd probably get some fun stuff back, but in the most part, they look something a little bit similar to this. They'd be like a little circuit board that you could put into a product. Strangely, you'd think, why do they always seem to have a shield on them? Why have they always got a bit of metal? But they'd have like an antenna port or a connector or something like that. You look at it and you think, okay, it looks like a little radio product, but clearly it's not really an end product. It's obviously meant to be installed into something else. So that's the sort of thing you would probably draw if I asked you to draw a radio module. You probably wouldn't draw one of these things. So these are just radio equipment as well. We've got a Wi-Fi, access points, phones, earbuds, watches. They're all radio equipment, just like the modules, but they look more like a final product. Okay, so let's have a little look at the regulatory process, and I'll pick on the main regions like USA and Canada. I'll loosely group together. I'll talk about the EU. When I talk about the EU, let's include Great Britain as well. So with the USA, radio transmitters must be certified to the FCC rules, and for Canada, radio transmitters and radio equipment must be certified to Canadian standards. So as a general rule, if you've got a radio product like a Wi-Fi access point or a smartphone or Bluetooth speakers, it requires certification. And if you install that product into some other thing, it loses its certification. If you took a smartphone and installed it into an air conditioning unit, or an Wi-Fi access point and installed it into a big printer, or some Bluetooth speaker to install into your washing machine, the certification of those radios would be lost because you've changed the product unrecognizably. However, there is a type of certification you can get for the USA and Canada called modular approval, and it's a special type of certification which gives the radio superpowers. And the superpower that it gives it is that it can hold on to its certification even after it's been installed into something else. It's actually a bit difficult to get that certification, so that's why every radio manufacturer doesn't do that. So you could say, well, why doesn't a Wi-Fi access point or a smartphone manufacturer, why don't they get that modular approval? Because it wouldn't meet the requirements. It's all about those little circuit boards. For example, antennas carefully controlled. The inputs and the outputs are carefully controlled. It must have a shield over its transmitter section, as you saw in those pictures. So there's a strict set of rules for radio modules in the USA and Canada, and that allows that module manufacturer to get a modular approval, which is a special type of certification. And the certification relates to the module itself. So that if you took that module and you installed it into another thing, like a laptop, an air conditioner, or a printer, or a washing machine, that washing machine or that end product would say, this contains, and it would list the certification number of the module. Certification is like a legal, traceable reference to the product. So if a module manufacturer wants to certify their radio module, they're pretty much going to test it standalone or sitting on a test jig, and there's this very strict set of rules about the construction of the module, and a very strict set of rules around the instructions that the module manufacturer gives to the installer, so that everything is very clearly laid out and controlled, because there's a very carefully written modular approval process. So the radio module is tested and certified on a test jig. Doesn't mean that that same module is guaranteed to pass all the tests when it's installed in the end thing, but it just means that the certification is in place. Now let's come across to the European Union. In Europe, we don't have certification of radio equipment. We have the Radio Equipment Directive. It's one of the directives that would apply, and it's all about declaration of conformity by the end manufacturer. And what does the manufacturer mean? It means whoever's name is on that end product, like some game of hot potato. So if you make a module and your name's on that module, you're responsible for that module. If the module goes into a laptop and the laptop manufacturer sells that laptop, whoever's name is on that laptop is the manufacturer of everything there. So in Europe, we don't have certification. So there would be no certification on a module, and therefore there's no transfer of certification to the host. So we do not have modular approvals in the EU. There's no such thing. In the EU, a radio module is just another type of radio equipment. So on my previous slides, and with your pieces of paper and crayons and your drawings, the radio modules are modules. They're radio equipment in the same way as the phone and the speakers and the watch and the access point are still radio equipment. They've all got the same legal classification. There's no superpowers authorization. If the module meets the definition of radio equipment, it should be CE marked so that it can be sold in Europe, even business to business. So strictly speaking, the only reason a module gets the CE mark is to allow the module manufacturer to sell the module in Europe. But in reality, we know that most people buying a module like to see the CE mark on it. The CE mark on the module doesn't give anything legally, but it gives the installer a warm and fuzzy feeling that at some point in the past, that module did pass some tests. So the CE mark doesn't transfer, but the module has passed some tests. And in fact, in reality, the test reports of the module might be very important to the installer, but the CE mark isn't really. So in Europe then, it's just another type of radio equipment. There's no rules over the construction of the module. There's no rules over how the installation instructions must look. And so you're kind of at a bit of a Wild West, get what you pay for situation in the EU. It's all declaration of conformity. There's no certification. The module was probably tested on a test jig or standalone. So all you really know is that that module passed the tests at some point when it was tested on its own. But that's good, they're still good. If it's a cellular module, that's a lot of testing that you're probably never going to change when you install it. So, USA and Canada certification, EU DOC. Now, you've got your radio module made by your radio expert, and you've got your Internet of Things or your end product manufacturer. And they now want to install that fantastic radio module into their own product to make it radio connected. So let's go back to this slide. The radio module was tested. In the USA, it's certified. So the end product needs its own authorization, but the certification of the module is already handled. In the EU, the radio was tested and approved, but the end product needs an approval as well. We'll look more closely at that on a later slide. In the USA and Canada, where certification exists, the certification was already handled by the module manufacturer, and so the certification of the transmitter, or like the listing of all the circuit diagrams and parts list and components, that's all handled and it's held on the FCC website under the module manufacturer's name. And then the installer or the end product manufacturer is just responsible for checking that their end product fully complies with all the testing. Now, it doesn't mean they have to repeat all the testing, but they have to know that it could pass. So they have to do enough checks, and we'll go into that in a few slides' time. So in the USA then, the radio module would most likely have the FCC ID on it and the Canadian certification number. And the host product, let's say the host was just some electrical device, maybe it will have been authorized under the SDOC procedure. And then ultimately, I thought it was too far away then. Ultimately, the end product, which would be a radio-enabled equipment, it would say contains FCC ID to reference the module, and it would have the SDOC of all the electronics. So the FCC in Canada, they split the authorization. So this laptop, for example, will have an SDOC for the laptop parts, and it will have a certification for the Bluetooth and a certification for the Wi-Fi. And the certifications for the Bluetooth and Wi-Fi might be in the name of the laptop manufacturer, or they might be in the name of some module manufacturer or two different module manufacturers. In the EU, where it's all about CE marking the end product, the radio module would be sold under the Radio Equipment Directive and CE marked. Let's say it's going to get put into a product which traditionally would have been an electronics product under the EMC Directive and the Low Voltage Directive, if anybody still uses those ancient documents. And then the end product is radio, so the EMC and Low Voltage Directives don't apply, only the Radio Equipment Directive applies to this end product. There's no contains module because there's no certification. Okay, so risk assessments. Anybody selling radio equipment into the EU is applying the Radio Equipment Directive, and they have to create a risk assessment. This is not to be confused with a safety risk assessment or a cybersecurity risk assessment. My personal opinion is that the risk assessment is a really badly chosen expression because there's so many other uses of the word risk assessment. It's more like a compliance plan. And as a manufacturer, when you're developing a product, it's really kind of the first document you open, that whole which standards are going to apply, which test cases are going to apply, which aspects of the RED are going to comply, what testing do I have to do? This is your risk assessment for the RED. It's your test plan and assessment plan. And although with the FCC, they don't talk specifically about risk assessments in their rules, they have said anybody installing a module would do a risk assessment to decide which tests need to be repeated or performed on the end product. So when you're putting a module into a product, what testing do you have to do? Well, certainly something like product safety would be fully performed on the end thing. And certainly all the EMC emissions and immunity testing would be performed on the end thing. Because those EMC tests are so construction-based that the EMC testing of a module bears no resemblance to the EMC testing of an end product. But when you come to radio performance testing, if anybody's done testing of Bluetooth or Wi-Fi or cellular, there's some radiated test cases, but there's also a lot of test cases just measured out of the antenna port, like the antenna, the output power, the bandwidth of the signal, the duty cycle, how often it hops, how many channels it hops over, does it move if some other radio is nearby. And if that's measured from the antenna port and you install the module and you don't change anything, you really haven't changed those results. And as a manufacturer, there's nothing that says you don't do that test, but you might choose in your test, in your risk assessment, I don't think I need to do that, and you would document that. So there isn't a definitive list of tests you must do, but there isn't a definitive list of tests that you don't have to do. There's lots of guidance documents, and I've written many of them, where they kind of say, if it's a radiated test, repeat it on the end product. If it's a conducted antenna port test, you could probably get the module's test report and accept it. But all of those documents have this little caveat of anything you think you might have changed, you are responsible for retesting. And when it comes to radiated testing, nobody's saying you have to do it all. You know, like the original module might have been tested over multiple channels and modulations and bandwidths, and you might just say, I'm going to pick the worst one or two, check them, and if it's looking good, I'm done. Ultimately, it's the manufacturer's responsibility. A lot of people ask test labs for help and guidance on this and say, what tests do you think we should do? But ultimately, there are standards that seem to present the answers, but they're guidance documents, and they have these little, if you think you've changed something else, then go and test that as well, caveats in them. So here's a product that I created, just as some examples here. So here's my product here. You can see from the antenna at the top, it's got its own radio product in it anyway, and then I've put two radio modules in it. So the two radio modules are both transceivers. They've both got CE marks. They've both got FCC IDs on them. My end product will just have a CE mark, and the CE mark of my end product will cover everything. It will cover its own radio and the two modules, so you won't be able to see those modules. Imagine they're invisible because they're inside. And then for the FCC, There's an SDOC procedure for the electronics, so I've put the SDOC logo on it. I've put an FCC ID on it for its own radio, and I've put contains FCC ID of the two modules. So you can see that the end product for the USA is able to reference those modules, in addition maybe to its own radio, whereas for Europe, it's just got one CE mark and one declaration of conformity for the whole product. So when it comes to things like testing, just as a sort of quick overview, let's say you've got a radio module, the module manufacturer did some spurious emissions tests on it. I'd really encourage you to look at the results of them and really think about it. Don't just blindly install it and say, what tests do I have to do? Look at the product. Where is your module? What were the emissions like? A lot of people say to me, well, surely if I install the module in a host, the host will provide some sort of shielding or attenuation to the signal. So any emissions from the module will surely go down. They won't go up. Well, that's actually not true. A lot of the time they do go up, because a little module just sitting on its own, no cables, nothing big enough to radiate a signal. As soon as you put it next to a circuit board with other cables and a screen and slots, the emissions can go up. And there's no set rules. If you've done it once in one host, it doesn't mean it will be the same in another host. It goes down to the size of slots and the lengths of cables. Speaking as somebody who has been, I started EMC testing in the late 1980s. I know what you're thinking. I was probably 3. But that was like a long time ago. So when people say to me, I've made a load of hardware changes, but I don't think it will affect the EMC, there's a reason why there's so many people making EMC measurements. So really know the product and investigate, and put it as an early development research part of your testing. And think about those conducted antenna port test cases, things like the output power. The module manufacturer didn't know your product, so they will have just tested it over a sort of medium, sensible range of temperatures in a nice, quiet environment. But actually, if you've done a lot of radio testing, you know that if you get it really hot, the signal can go noisy. If you get it really cold, the amplitude can really go up. So if your product's on a vehicle, and it's in Finland in winter and Greece in summer, is that module's radio performance actually going to be the same? And it's not just the transmitter, the receiver as well. That happy little module was tested standalone inside a nice quiet chamber, and its receiver performance was very good. And then suddenly, you're going to put it in a noisy product with other signals around it, and maybe even another radio right next to it. We see a lot of cases of radios where, when they're acting together, they interfere with each other. And so the same people who said, well, why do I need to repeat my emissions? Because surely the enclosure will attenuate any signals. You then go, well, so you're also saying that it makes the receiver performance worse because it's going to attenuate the signals. So again, it's a bit of an elephant in the room test, this. People don't want to do it. So my takeaway on modules are good. It sounds like I've got a downer on modules, but I really haven't. They're a great thing, and they're a great way of getting manufacturers of products, allowing them to be radio enabled without having to hire a whole radio team. But the final authorization needs to be in place, and the final product needs to comply. You don't need to have a full set of test reports of the end product in most cases, but you need to know that it would comply. Think back to your end goal, your original goal on my second or third slide. It has to be a good quality product. And the final company with their name on the product takes all the legal responsibility. So some common mistakes. If the module manufacturer and the installer are a bit too transactional, I'll buy a module, thanks very much, I'll go and install it. I would really encourage you to pick a radio module manufacturer with which you can have a sort of relationship, especially as we get into the world of cybersecurity, where the module may have had a cybersecurity assessment, but it's probably quite minimal, and it may or may not relate to the cybersecurity assessment you've got to do on your end product. You'll suddenly find yourself thinking, wow, I thought doing the radio testing on somebody else's module was hard. Now I've got to do a cyber test with somebody else's module. Thinking it's plug and play. Anybody who's been... CE marking came around in the early 90s, and I can remember at the time people saying CE plus CE does not equal CE. And it's still true, and it's very much true with radio modules. Not testing the end product, and thinking it's simple. So in my years as an engineer in this industry, I've tested state-of-the-art base stations, state-of-the-art smartphones, watches, really fancy glasses that will be on the market one day, and yet to this day, the most complicated thing I get involved in is installing a module into some other thing. Manufacturers take different approaches to this. I've spent a lot of my time in the past, people contacting me and saying, I've got this product, I want to install these modules, here are the test reports, what can I do to minimize my time at the test lab? Or maybe they've got their own internal consultant, and so you create like a test plan. But it could take a really long time and cost a lot of money to avoid doing the testing. Other manufacturers just go, I haven't got that time, I haven't got that expertise, my test lab has availability next week, just test it. Just test it and I don't want to have to think about it. But ultimately, time to market is your friend, and a good quality product on the market is your ultimate goal. People talk a lot about market surveillance. I was in a presentation earlier, they were talking about market surveillance, and people worry, well, what if I get caught? That's not your real worry, actually. Market surveillance is not your real worry. There's not that many people get caught, and all you really have to do is say, I'm sorry, I'll fix it. Your real worry is that you're going to sell products that don't work very well, and you'll get bad reviews, and then your sales will go down. That is a much, much more painful proposition than market surveillance. So if you're selling a product and you haven't tested it and you haven't developed it and you don't really know if it's working correctly or not because you just chucked somebody's module in, that's quite a risk. So doing it right is a much stronger driver than getting told off. And similarly, if you've ever played hide and seek with a really small child and they're supposed to be hiding, but they just shut their eyes because they think, well, if I can't see you, you're not there. And people have that sort of same thing where they say, I've installed a module, do I absolutely have to test the end product now? Because the module passed, when I've installed the module, do I have to test it? And I go, well, the end product has to pass. And they go, yeah, but do I have to test it? And I go, well, how else are you going to know unless you at least check? I'm not saying fully retest everything. I'm saying, how are you going to know? So if people say, do I have to have the module on? Do I have to have all the modules on? And again, if you're selling a product, if you haven't at least looked, there are a lot of people who say, I don't want to test it in case it fails. And you think, okay, what is your end goal here? So working in a test lab, the most success we see is when people engage with us early, come to us and say, we're developing a product, we've got some prototype, we've installed a module, we want to know, is it likely to pass when we come? What you really want is when you come in for your final test and certification, you can just put it in the lab, pour a coffee and sit back and relax because you know already it's going to pass. All right. Whew. I haven't left a huge amount of time, but I will gladly take any questions. All right, everybody's an expert on radio modules. That's good. All right, well, thank you very much. Oh, there is a question. Fantastic.
Compliance testing.
How long does the process take?
Yeah.
So,
does it differ with each prototype or the complexity of the design? Or
yeah. That's really
or is it like a country thing?
Exactly, it can really vary per country. So for Europe, and there isn't harmonization of testing approaches. So let's say you were wanting to place a product on the market in Europe, and Great Britain has obviously just kind of recently said, like, we'll just take CE-marked products. And so your product safety testing, I might even ask one of my colleagues how long product safety testing takes. EMC testing could probably be like a week, depending on how complex the product is. Bluetooth earbuds could be like a couple of days. A smartphone could be weeks, 2 weeks. Safety, about 2 weeks. We Element, we test some real top-of-the-range smartphones where the EMC testing can take weeks and weeks, but you could also have a Bluetooth product tested in maybe 2 days. And again, with the radio performance, like each radio function might be, let's say, 3 days. So if you've got a Bluetooth speaker, 2 or 3 days and you're done. If you've got a smartphone with lots of bands, and then it becomes really, if you're wanting to go cellular, then that comes really quite a lot of testing involved. So the pre-compliance testing, I would say it can depend on how much you want to do. You kind of want to find a lab you've got a good relationship with where you can go in and just say, can you just do a quick emissions, like a half a day check? How is it looking? And you'll get a really good feel of a half a day or a day of just how bad is this? And then if you wanted to sell into the USA, there's different limits, there's different test methods. It's not just saying, I'll make one set of measurements and put 2 limits on. They're like animals that have evolved in isolation to each other. And so there's different methods, and there's different detector type and bandwidth. So you can't take one set of results. But if you do a quick scan, you can look and kind of go, it's awful, it will fail both, or that's looking really good, I don't think we'll have a problem. And I would really encourage you to kind of get that feel of, what happens if we do this, and what happens if we do it? If we move this cable. And so if you change everything, and everything still passes, you put your module in, for example, and you found that you move cables around, and you move connectors, and you put it here, or you put it there, and it makes no difference, you can just relax. But if you find, right, we move this cable, wow, it fails, it's awful, and then we move it back, it's fine. You kind of got choices. You could say, let's redesign it so that doesn't happen, or let's tell manufacturing it's really important to clip this cable to the case. So you know all that before you get there. So that whole 2 or 3 days testing, or 2 weeks for safety, that's assuming everything passes. If you start getting to, and you know, the trouble is, if you've got a lab where the lead time is 3 months, and you go for a test and it fails, and you go, oh, it failed, I'm going to get manufacturing to clip the cable to the side, or you use some tape, and they go, that's great, but our next slot is in another 3 weeks' time. Yeah. What costs the most? Well, interestingly, yeah, in test lab world, it tends to be the more unusual new technology tends to use more sophisticated equipment. So, for example, if someone comes to us and says, can you test Wi-Fi? We go, of course we can test Wi-Fi. And if it's like quite an old, like Wi-Fi 3, Wi-Fi 4 in the 2.4 gigahertz band, that's such a well-established technology now that it's quite cheap and quite easy. Whereas if you say we're using Wi-Fi 7 in the Wi-Fi 6E, 6 gigahertz band, you've still just got Wi-Fi, but the rates go up because we've had to invest in the state-of-the-art test equipment. We've got to use a test simulator to get your Wi-Fi to work. So you've got things like, you know, safety testing has a pretty fixed rate, and radio testing may seem like it's got a fixed rate, but it can depend on the more complex it is, like cellular testing. A lot of the cellular testing in Europe overlaps with a group called the GCF, Global Certification Forum, and it's all about how the radio works, and that can really ramp up. And if you have a radio transmitter that you would wear on your body, and it transmits at over 20 milliwatts, then you need to start thinking about what's called SAR testing, specific absorption rate. That's not a cheap game to get involved in, but quite important. I hope that helps. But come and see our son's booth K3, and we'll gladly talk through much more detail about that. Cool, thank you.